in progress.
You are here because you would like to excel in acid, base, and salt chemistry by the help of Abel's chemistry. I had wanted to create what you call an animation for this video, but due to the current time constraints for O levels, I didn't really have time. And moreover, I'm new to chemistry. I'm new as a YouTube creator, so please excuse me for this. Okay, so now we're going to do acid base and salt base and salt. This is essentially part one because I want to talk about the introduction to acids and bases and of course the basicity, right? For the things like chemical reactions, I'm going to talk about it in a separate occasion. Okay, so so first things first, right? Acid is defined by an acid is defined by an ability to be able to dissociate into H plus ions, right? So the presence of H plus ions is actually what makes something an acid, right? So acid is most famous for its H plus, right? And of course base is most famous for its OH minus. Okay, but then the thing is what you all have to know, what you all have to know is something, okay? Many people think that this is a common misconception, especially when it comes to MCQ, right? So some MCQs will ask you about the concentration of acid and of OH plus and OH minus ions. The truth is, as many of you think that, unlike what many of you think, acid have a low concentration of OH minus and base have a low concentration of H plus. Then some of you might ask me, how is it so? Right? The answer is actually because because acid and bases, they do dissolve in water. So the facts that dissolve in water do make it an aqueous medium. Now, water is actually H2O. So H2O undergoes auto ionization to form H plus and OH minus ions. Right? So by right, acid should have some OH minus, just that the concentration is very, 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 very low, right? And then the base, again, it has a low concentration of H plus, just that the H plus concentration in the base is very, 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 very low, right? So in the acid, the concentration of H plus, right, is much higher than the concentration of the OH minus, and hence its acidic property. And for a base, the concentration of OH minus is much higher than the concentration of H plus, hence rendering its basic property. So, okay, some of you might actually have asked me for the difference between like what's a base and alkali, right? So, the answer I have for you is that a base, right, is essentially the soluble version of an alkali. So let me give you an example, right? Now you know that sodium hydroxide is a very common base, especially when you use it in lab, right? Right. So, but then like I say, the oxide is a base, right? So later on there'll be one part that talk about metal oxides, right, and metal hydroxides, right? So usually bases can be anything that it is that so bases can be anything that is insoluble in water, right? Then when it's alkaline, it's actually soluble in water to give OH minus ions, right? Again, right, the strength I'll talk about it later, right? But then bases, they are usually actually alkalines are a subset of bases, right? They are a subset of bases. I'll give you one very good example, right? There's one example that I want to talk about is actually with regards to metal oxide with metal hydroxide, right? So okay, so let's say I have a metal M of group 2 charge, okay? Let's say let M be a metal in group 2. Group 2, the charge is equals to +2. So this is the metal oxide solid. You notice that when you try to dissolve it in water, so you add one more of H2O. Yeah, notice it's going to form. So this 2H here, this 2O here. So just nice. This is MOH2, right? This is aqueous. So this is the metal hydroxide. And this is the contributor for your OH minus ions, right? Then this one, right? This one, um, is also this is actually the metal oxide, right? So this is a base, right? This is an alkaline. So some metal oxides are insoluble in water. Actually most metal oxides are, right? Um, like I am pretty sure, right? I can give you an example. Um, Magnesium oxide, it is partially soluble in water. It's called sparingly soluble, right? But that means it doesn't dissolve fully. It only dissolves like partially, like only a very little bit, right? So, this is what I meant. Okay, so this is the responsible for the OH minus ions, right? So the point I want you to take note of here is also that metal oxides and metal hydroxides, they are equivalent to each other. They are not the same because of the different chemical formula, but they're equivalent to each other. When metal oxides that are dissoluble in water gets dissolved, they are going to form metal hydroxides. All right. So okay, then this one. So now, without further ado, I'm going to talk about the most common thing. So this is the pH. So many of you people, the school teachers, they don't teach you what is pH. So for your info, pH is a measure of the concentration of H plus ions in a solution. For the formula of pH, you're only going to learn in A levels. Okay. So for your info, right? For your info, okay, never mind. I don't want to teach you because I think this will confuse you. So anyway, lower pH means higher concentration of H plus ions and vice versa. So three factors that affect the pH, the pH, right? Firstly, the strength of an acid, and this is when your definition of the comes about. So for a strong acid, you have to, and the weak acid, when discussing the strength, you have to take note of the keywords. So they say dissociate or ionize, dissociate or ionize. This one. So this is the feature. This is the feature of the strong acid, right? Fully or completely. This is the feature of the weak acid that it only dissociates partially, right? Or ionizes partially. Then you must say dissolve in which solvent. So this acid is actually the solvent is water, right? So this is also another difference, right? To give a high concentration of H plus, right? So when dissolved fully, right, they'll give a high concentration of H plus ions. But when dissolved partially only, right, it's only going to give a low concentration of H plus ions. So you have to take note of this. This actually brings me to the equation for dissociation, right? So I let HA be an acid, and then it's going to dissociate into H plus, aqueous, and of course, the anion, right? The A minus aqueous. So when it's a strong acid, you have to show a full arrow to do a complete dissociation, right? And here is where some of you may tend to make careless mistakes, right? So weak acid, right? Weak acid, you will notice that it's going to be a reversible arrow because you need to show the partial dissociation only. And this is what results in the low concentration of H plus ions, right? So let me give you examples of strong acids and weak acids, right? So strong acids, three common ones that you know in your lab are HCl, right? HNO3, right? H2SO4. This one all very famous in your lab. So these are minimally what you have to know, right? Weak acids, they are usually your organic acids. And to in O level, it's called what acid? It's called your carboxylic acid, right? Another one I can give you is your H3PO4, right? H3PO4 is considered a weak acid, right? If not, it's mostly the organic acids, right? If not, I think for others, right, the question will likely hint to you whether is that a strong acid or a weak acid. But I think they will likely hint to you. Actually, I want to give you one more, right? So carbonic acid is also a weak acid. I think this is also worth knowing because if you have to relate this to your air and atmosphere, your air quality chapter, right? Your air quality chapter teach you that carbon dioxide is actually a slightly soluble gas, right? It's a slightly acid gas because when it's soluble in water, it produces this weak acid called H2CO3, right? I can give you some more, but these are just for your info only, right? So these two are just for info. There, this is sulfurous acid, right? This one is nitrous acid, right? These two are just for your info. Okay, can? Yeah. Then without further ado, let's move on. Okay, so next thing is consent concentration of an acid ion. So of course, the higher the concentration, the higher concentration plus, and of course vice versa. I'm not going to go through this. Okay, then let's go to the basicity of an acid. So now this is a base. So this basicity of an acid is super important because this basicity of an acid is going to lead you into titration later in your mole calculation. Okay, so basicity of an acid means 1 mole of acid basically dissociates to give you how many mole of H plus ions, right? So 1 mole of acid, so as you can see, this one is monobasic, right, or monoprotic, right? So there are two names for it, right? So the word mono means single, right? So when you say single, it means 1 mole of acid will produce 1 mole of H plus. So for example, these are two common acids in your lab. You should know them by now, right? HCl, HNO3. When they dissociate, they only form you 1 mole of H plus aqueous. Dibasic diprotic acid means for 1 mole of acid when they dissociate fully, right? So actually, this one, right, is assumed they dissociate fully, right? So this one, right? Then 1 mole acid and it dissociates, it's going to give you 2 mole of H plus ions, right? Okay, so this 1 mole of sulfuric acid, 2 mole of H plus ions. Tribasic, triprotic, right? So it's H3PO4, right? Actually, wait, I'm sorry, I forgot, right? H3PO4 is actually a okay. Actually, no, you should you shouldn't assume they dissociate fully, right? Even those that dissociate partially are also like that, right? Because the thing is they dissociate partially, because even if they dissociate partially, right? For every a little bit of for every no matter how much acid it dissociates, right? It's still going to give you thrice the number of mole of H plus, right? So this one should actually be a reversible arrow, huh? Okay, so 1 mole H3PO4 is going to dissociate partially to give you 3 mole of H plus, right? Okay, so how do you swap? Here's actually a trick for you. How do you determine whether the acid is a monobasic or dibasic or tribasic acid? You just look at this number, right? You look at this number. So here, the number of H is 1. So by balancing the equation alone, you can only tell that it's really 1. It's 1 mole of H plus equals. This one, the number here is 2. So by simple balancing of chemical equation, it's going to give you 2 mole of H plus ions. This one over here, right? The number here is 3 for a tribasic acid. So by simple balancing a chemical equation, it's going to give you 3 mole of H plus ions. Right? Another thing that I want to talk about, right, how to determine the basicity of an acid using mole calculation is with regards to what you call is this thing on what you call they can give you a titration curve for neutralization. So let me tell you first. Let me tell you first, okay? So titration curve for neutralization. So first things first. Okay, so let's say, okay, so the number of, so let's say the moles anyway. Let's say the base, right, is NaOH. Okay. Now, usually, right, it can be determined the number of mole of NaOH that reacts. Okay, so let's say I give you, right, e.g. monobasic acid. Like, what's your famous one? HCl, HNO3. This one very famous. Here you go. HCl aqueous plus NaOH aqueous, right? Will give you NaCl aqueous plus H2O liquid. Here you go, right? So what's the mole ratio here? This is 1 mole, right? Is to 1 mole, right? Okay, so then next one, dibasic acid, right? Dibasic acid. Right, like your most common is H2SO4. So H2SO4 equals, right, plus NaOH, right, equals, right, right. This salt, when it neutralizes fully, it should give you Na sodium. So we are going to do a sort of partner. So Na and the SO4 is going to come here. Right. So it's sodium sulfate. So the SO4 is 2 minus charge, and it's only one charge. So I need to write a 2 here. Right, SO4 equals, right. Then there are how many H here? So there are 2 Na here. I need to balance with 2. Right, then there are 4H. So it's going to be 2H2O liquid. So down, do you see, right, that then is 1 mole, right? This one is 2 mole, right? So the conclusion is, can deduce basicity of an acid by number of mole of NaOH required to completely neutralize it. Okay, so yeah, as you can see here, so it ultimately depends, right? Because somehow H plus and Na plus, they have the same charge. It's okay, but you know what? I think I'll talk about this in ionic equation, right? So this is just to keep it simple for you to know first, okay? So the number of mole NaOH that reacts is okay, the amount of mole NaOH can react over here, right? Is can help you determine the basicity of acid, because essentially it's just a swap of partner, right? The H2, they swap the partner, right? So the Na2 come here, right? Instead of H2. Then the H2 and the oxygen, they go where? They go and form water over here. Then the SO4, they remain. The Na2, it comes here. So it's basically just a swap of partner, right? It's just basically just a swap of partners, right? The swap of the partners of the cation and the anion, right? So I hope you understand how this works, right? Because I had 2H here, right? 2H here. So I need 2 Na to react away, right? So then this is going to be Na2. Okay? Now, so actually, let me talk about one thing, right? The pH curve, right? So the pH curve, right? So for monobasic acid, right? For monobasic acid, so let's say this is the pH, right? This for titration, right? So this is, let's say, the pH, right? This is, let's say, in the burette, let's say I put volume of NaOH equals added. For monobasic acid, very easy. It is just going to be like here, right? And then there is going to be a sharp change in pH at the equivalence point, right? So this is monobasic acid. then this one here is called your volume of neutralization, right? At the equivalence point, right? And then of course, this is going to be your equivalence pH. All right. So this this equivalence point, right? This equivalence point, it comes when 1 mole of NaOH completely neutralizes 1 mole of monobasic acid. All right, Ken? Okay, so let me move on to dibasic acid, right? Okay, so let me see here. Okay, now we move on to dibasic acid. Okay, so dibasic acid, right? And this one is our highlighted in DBQ because this is this is especially important for database question. This is actually not in your syllabus, but it can come out in DBQ. So right, so let me teach you, right? Okay, so again, I'm not going to write it over here. Like this, just the same thing. So right, so okay, some of the pH curve, right? They actually teach you all this, So they actually see this, right? They actually say, ayo, okay, they can actually see this, right? Then you all got sharp pH change. Then you go up again, you got another sharp pH change, right? So now, if you don't know what is going on, okay, now there are so basically, right? If you don't know what is going on, now let me tell you, right? There is actually a stepwise dissociation of an acid going on. Sorry, H2SO4, right? It does not dissociate into 2H plus automatically. It undergoes stepwise dissociation, right? So basically, what's going on? So when H2, e.g. H2SO4, right? So H2SO4, right, is going to dissociate into H plus aqueous plus SO4 2 sorry, this one is HSO4 minus aqueous. Then this HSO4 minus is going to dissociate again, right? So HSO4 minus aqueous, right, is going to give you H plus aqueous plus SO4 2 minus aqueous. Right, so this is the stepwise dissociation of H2SO4. So what is actually happening here, right, is the first volume of neutralization. Is when this is when 1 mole of NaOH reacts to 1 mole of dibasic acid. So what's going on here is this, okay? H2SO4 aqueous, right, plus 1 mole of NaOH aqueous. It actually gives you NaHSO4, right? Sodium hydrogen sulfate, right? The N ion is hydrogen sulfate, then plus H2O liquid, right? This is when this then so 1 mole H2SO4 completely neutralized by 1 mole NaOH, right? Then the salt is NaHSO4. This one, okay, this one, the second VNew. So the second volume of neutralization, right? Okay, so let me write here because I know space, right? So this is the one that you all will usually write, okay? So then plus So this one is going to be 2 moles of NaOH aqueous, right? Mind me, okay, 2 moles, what the hell? I don't know how to use my pen. What happened to my pen? NaOH aqueous, right? It's going to give you, this one is Na2SO4, right? Because Na2SO4 plus 2 moles of H2O or another or aka, right? So basically the NaHSO4, right? The NaHSO4 equals, right, plus another mole of NaOH, right? Correct or not? Okay, so another mole of NaOH, right? So it's going to give you so this one is still partially an acid, okay? So because the presence of H plus here, so make it an acid, right? So this one is going to give you Na2SO4 aqueous plus H2O liquid. Okay, so I hope you actually understand what is going on here. Then this thing, I want to talk about this thing, right? This is called the sharp change in pH, right? Again here, sharp pH change. This one over here also, right? Sharp pH change. So this sharp change in pH, right? Sharp change in pH, right, is going to use how to choose an indicator suitable for titration. Ladies and gentlemen, this is 1 mark in your O-level chemistry. So please go and memorize and understand it. So the indicator chosen should have pH working range. Right, this one, pH working range that corresponds to the sharp increase in your pH, right? If let's say you were asked why no indicator, right? Indicator is suitable. It's likely because weak acid or weak base titration, right? So weak acid, weak base titration, right? So this means there is no sharp change in pH, right? So therefore, color change is gradual, thus hard to determine exact end point. And this is very common in your database question. Okay, can? So you all should also know what are strong bases. The most common weak base you should know is what? The most common base you should know is ammonia. Right, ammonia. Okay, so last thing, but this before I want to end this session, I actually wanted to show you this, right? So this, right, is the so this is actually the so this is actually some common indicators, right? For O level, I think it will be okay. So you'll see thymo blue, right? You'll see thymo blue. You'll see methyl orange, right? You will see methyl red. Methyl red. Do you all use I'm not too sure, but methyl orange is more common, right? Methyl monomethyl blue, right? Phenolphthalein, right? And then dimethylene. But then I think these two not dimethylene, I think they don't test it anymore. Okay, so but anyway, right? So as you can see, right? I can see, right? Okay, this one, especially midnight orange, because midnight orange is so common, okay? So this, as you can see, this is the region of where the color change is. So when this is the region of where the color change is, what this means, right? This is what you call the working range. Working range, right? So this is the working range of the indicator, right? Or rather, the working range, right? Or the rather, it's called the pH working range, right? So the working range is between pH 3.2 to pH 4.4, because that is where they change the color changes, right? The sharp color change, right? Then over here, right? Over here, it is shit. Okay. Over here, right? It is basically in acidic medium. Acidic medium. So in acidic medium, beta orange is red. In alkaline medium, right? Alkaline medium, right? Meta orange, right? The color is yellow. Right. So this one is alkaline. Right. So you really just have to look on which part of the pH graph, right, corresponds to the sharp increase in pH, right? So they will label it for you. Then you go and check with this, right? You go and check with this. You go and compare against the list of indicators and check which pH range is the working range of the indicator where the sharp color change is. You compare them, there you go, you get your 1 mark for O-level pure chem and combined chem also. All right, so I hope this session will help, and thank you for your attention with Airbus Chemistry. I hope to see you in the next session. We will continue on acids and bases. Thank you.